We are going live now. Yep.
Cool. Just waiting for confirmation that it's working. Let me cancel my current Houdini session. Awesome. Okay. Hi everyone. Welcome to our second stream. Today we'll be talking about a couple of things based on some of the things that we want to show, but also some of the things that you guys have asked for. So what I have planned to start with, at least, will be showing the new Instant Meshes tool. We've had it in the past, but one of our interns, Ro, he actually took the source code of Instant Meshes and integrated it, deeper into Houdini using HDK, or the Houdini development kit. So we'll be showing that. I'll also be demoing Physics Painter because last week we got asked to actually, show that. I'll be showing some Maps Baker stuff. I'd like to show the insides of it, like how does Maps Baker work on the inside. Just a brief explanation of that, because it seems that there is still some unknowns there for certain users. And last but not least, for automation, I'll be showing some of the stuff from the Quixel Rebirth project, and I'll also be showing some of the smoke test stuff that we use to test our tools internally. So let's just wait for Houdini to start, and I should also share my screen here so that Mike and Louise know what I'm doing. Cool. All right. So let's start with the first thing that I mentioned, which is the new instant meshes. So I prepared a quick scene so we don't have to look for files on disk and so forth. And this is just our Alfred Jacquemart BGO high-res geometry, right? So as you can see, as soon as this loads properly, we can see that this is a really high-res mesh. If we middle mouse this guy here, we can see that it's almost 3 million polygons, and it's a tri-mesh. But what artists frequently want, especially for characters, but also for having a clean mesh in general, people would like to have quads, right? For all sorts of different reasons. And Instant Meshes is one of those third-party solutions. It's open source, it's free, that allows you to take any piece of geometry and feed it into that tool, and it will spit out a quad mesh like this. So we've had the Instant Meshes tool before, but how that worked is you had to download an executable to disk, and then through command line, which is essentially just us running a different application through Python, it would call Instant Meshes, and Instant Meshes would save this geometry to disk, and then Houdini would load this geometry back up again. I think if we just quickly create an Instant Meshes and set it to use a different version, or the older version, we can see how that worked. So I'm just quickly going to enable my assets bar here under configuration, asset bar, display menu of all definitions. So what this allows me to do, if I move this guy here, we can actually change which definition of instant meshes we want to use, or any other GameDev tool that we've made in the past that has got a big update where we've pushed the version. So by default, it will always use the newest definition that we've published, which now is 2.0. But just to show you the inside of the tool, I now switched to version 1, and as you can see, the interface was different there, and you had to set the executable here. So if we dive inside, we can see that how this tool worked. We had our geometry coming in. It would save the geometry to disk. We'd have some Python code here, which creates a command line argument. So it basically says, take this executable at this location, use these arguments. For example, I want to have this many polygons. I want to have quad dominant geometry, which then saves it to disk. And that's what, let's see, a different node in here does. Cache output, probably this one or the one above, adds some normals to it and outputs it back out. So that's how the old one worked, but the new one works differently. So let's just create another one and make sure that it's 2.0. It is. If we dive inside this guy here, we'll see that it once again has a network as well. But the only thing that this guy here does, is just deleting some attributes, so it's easier to process. It triangulates the mesh before it goes into instant meshes. We have our guide curves. This is something completely new in version 2. And then we have this node here, which says instant meshes. And this node here, as you can see, it doesn't have a lock icon here. This means that it's an HTK node. It has been compiled, and it's a DLL that gets loaded by Houdini, giving us this native node. So for version 2, we can also see that it has 2 inputs instead of just one, like this one here. So what are those 2 inputs? The primary input is just our geometry, and the secondary input is, let me just hide mic real quick. Can I just click X? Yes. Okay. The second input is guide curves. So what can we do with guide curves? With guide curves, we can basically tell instant meshes in what direction we want the quad flow to happen, right? So we've seen that we can simply set a polygon count and it just, remeshes this like we want. But if, for example, we use the rubber toy, just drop that one down there. See, there we go. And we plug in our instant meshes and set this to something like, I don't know, 5,000 or something. It's probably more than we need, but it just gives us a nice mesh to work with. And as we can see here, these are a bit, skewed, or they're not completely straight. But what if a user would like these to be completely straight, right? Or they would want to have, something else going on here. That's what the second input is for. So how can we do that? We can, for example, use the draw curve SOP, where we just plug in our geometry. And then as you can see, by default, it will give us this blue grid. This is the geometry that the draw curve SOP is projecting on, right? So if we were to draw on our screen, we would see that it draws on that flat plane. But we want to draw on our geometry. So what we can do under the projection tab is change this projection parameter and set this to be geometry. And now if we zoom in, we can see that we now have this blue piece of geometry, which is our collision geometry. So now if, for example, we select our node again and hit enter, we can draw on this guy. So now, for example, we can draw a curve like that, just straight like that, and we can feed that into the guide curves input. And once we click the visualizer there, we can see that now we have a quad flow exactly where our line was, following the direction of that. So if we were to disable this guy, we can see that now once again it's skewed like this. But if we plug it back in, we now have our quads flowing in that direction. And we can, feed it as many curves or guide curves as we want. Another cool thing that version 2 has is the output of flow lines. So what are flow lines? Flow lines are basically what instant meshes calculates internally to figure out how to make the quads, be laid out on your topology. So if we enable output flow lines and we middle mouse on our instant meshes SOP, we can see that we have 2 primitive groups, one of which is our geometry. This is, the quad mesh that we see. And the second one is the flow lines. And you can already sort of see them here with these white lines. But I am going to use a split SOP to quickly split those 2 apart from each other. So I'm going to set this to be geometry. And now we have 2 different streams of data. We have our quad geometry on the left, which we have here. And we have our flow lines on the right. And these guys here are, like I said, what instant meshes uses to figure out how the quad topology flows. So these, could be very useful for people doing effects or something, right? You can use these to, for example, emit particles or generate some sort of tangents or other types of vectors, right? But if you don't want them, once again, just disable it, and it also saves you some overhead from calculating those. So I'm just quickly going to look at the stream chat to see if you guys have any questions regarding this.
I think we're good at the moment, Paul.
Yeah, awesome, cool. Yeah, we want this stream to be interactive, right? It's us showing some stuff, and you guys can ask questions, either about what we're showing at that moment, but also requests about what you would like to have us show next. So that's what we have for instant meshes right now, I believe. So for the next topic, I'll switch over to Physics Painter. So I'm going to open Physics Painter. Oh, there we go. We can discard this guy.
While that's loading, Paul, is there anything that users should be aware of when they're using the new Instant Meshes tool in terms of gotchas or things that still need work?
We haven't found any major problems yet with the tool. There are some improvements that we would still like to make. For example, sometimes you see that the output of instant meshes has lots of weird quads because it tries to merge multiple flow lines of quad topology together. But there is an option that, for example, says don't force it to be just quads. Triangles are also allowed in some cases, which then gives you somewhat better geometry. And so that's one of the things, and a couple of others which I can't quite think of right now. But there are more improvements coming. Right now, Instant Meshes version 2 is only for Windows. Linux is coming as well. We just need to compile it on a Linux machine. We haven't had time to do that yet. So that's on the way. I don't have an ETA on that yet, though. So the next thing, Physics Painter. Last week we showed where you can find Physics Painter, the demo scenes, but now I'll actually show you Physics Painter to make sure that you understand how it works and to perhaps give you some cool ideas on what you could do with it. So to begin with, I have some lights in this scene, I believe. Oh, I don't. Great. So what is Physics Painter? Physics Painter is basically a tool that allows you to take a static piece of geometry. So for example, a grid with some noise on it, right? So this could be, rough terrain, or it could be a table, or it could be an entire, level, or it could be anything else. And then Physics Painter also takes in physics objects. So what are physics objects? Physics objects, could be just a cube, it could be, a sphere, it could be a pig head, it could be candles, it could be coins, it could be anything that you want to simulate using a physics simulation on that static scene that you've seen before. So how do you set it up? Well, it's really simple. You create your Physics Painter SOP, right? So you just type Physics Painter and it'll show up there. And then you'll get this interface you see here. We have a couple of buttons here. Dry Current Paint. We'll click on that one as soon as we've started using it. We can click Clear Current Paint. This will clear any of the physics objects that you're currently painting. Activate all paint will reactivate all physics objects, and clear all paint will just basically reset our scene so that we're just back to where we started with. So in this case, just this grid with a mountain attached to it. So to add objects, there's a couple of ways of doing that. You can simply drag and drop a node here into the quick add parameter, and it will automatically add them here at the bottom. Or what we can do is we can just say add an extra one. So we type 4, and it will add a new field here. So what do we put in these fields? In these fields, you put your physics objects, and it has two main parameters for you to fill out. The first one is your simulation mesh. So in this case, with my cube that I have in an example, we just want a lightweight piece of geometry that is easy to simulate with, right? So if, for example, we have a high-res version of this cube, I just subdivided it to make it high-res, but this would be your high-res geometry. We would want to simulate with this low-res geometry because then the simulation happens faster, right? A better example is the pig head. The pig head, for example, has lots of these convex pieces here, where if lots of pig heads would stack together, if for example we use a tetrahedralize or shrink SOP, shrink wrap SOP. Oh, that's not the right one. Shrink wrap. We can see that this would be the collision mesh that Houdini would generate by default for your pig head. And if we look at the pig head, this is not really something that we would want in our collision simulation. So that's why we have our render mesh, in this case, the real pig head without any modifications. And then for our simulation mesh, we can use, the convex decomposition to once again basically use this shrink wrap, but have it generate multiple pieces so that it better adheres to our shape. And that's what we put in here. Our simulation mesh, which in this case would be our convex decomposition or our low-res geometry, and our render mesh, which is our high-res pig head or our high-res cube. What the tool does is it will simulate using the low-res, but as soon as you're done, it will actually instance the high-res onto the low-res geometry that you simmed with. Then we also have this weight parameter. This weight parameter basically controls the randomization of when you're painting with geometry. So if I hit enter while I have the physics painter selected and I draw a curve, we can see that it doesn't just draw the first mesh, but it actually picks at random between the meshes that we fed into the tool. And that is what the weight one does. It's a weight at random. So if we were to increase the weight of this guy here, which I think is our cube, we will see that we will have more cubes, but less of the other ones. If we want to have more pig heads, we just increase the weight of the pig head, and it will have more pig heads. So these values here, they don't need to all add up to be 1 exactly, right? So this doesn't need to be, for example, 0.3 and 0.3 and 0.3. It's all relative to each other. So the higher a number is compared to the rest, the more the higher the chances that that mesh will be picked to be instanced, right? So now we've figured that out. We also have some DOP settings. So these are some of the physics properties of the geometry that we just fed in. For example, the density or the mass or the bounce or the friction. These will directly influence the simulation that's happening. So then we also have some static settings. So these are just general physics solver settings. For example, what's the gravity like, or how many substeps do we want? Do we want to have drag? Do we want to have a ground plane? I disable it because we don't really need a ground plane for this scene. But now we've set it up. That was the boring part. Now we can actually get into the fun. So we just hit enter again to get back into our physics painter state. And then what I'm going to do is just press the play button, and we will see that it actually now directly simulates what we just drew with our stroke, right? And as soon as I like the frame that I have, I just click stop and scroll up, and that's when we'll use our dry current paint. So I click that, and as we can see, our objects turn from green to gray. What does that mean? Gray objects are part of the static group. So now these guys here are considered to be part of the terrain that we have. So what I can do now is I can once again draw. In this case, I'm not going to hit play here, but I'm going to use the arrow key that points to the right on my keyboard and just hold that. When you hold it, it will basically just push a frame forward, essentially meaning increase a step in my simulation, which means that I can scroll back, I can scroll forward until I find a frame that I like, and then I'll just hit dry current paint again. And I can just keep doing this as many times as I want until I have something that I like. There we go, I like that. So that's that button. Clear current paint, like it says, it just clears the active pieces of geometry that we have. So I just click that, and it got rid of the stroke that we have there. And clear all paint, be careful when you click that one because it will delete all the objects that you've painted in the past. Also good to know is that Physics Painter creates this sort of this data container that we have here. And this data container basically contains all our geometry that we've painted. So that's our latest update. So that's just a good to know. You don't need to look at that if you're just using Physics Painter, because Physics Painter has two outputs. It can output everything. So, our static scene plus all the packed primitives that we have. So as you can see, 27, but it can also only output the packed objects. And as you can see, we have 25 packed objects there. So this allows us to, for example, extract the transforms or plug that into our static fracture exporter, which then allows you to export it as a point cloud or as an FBX with unique pieces of geometry. If you're exporting a point cloud, you could directly load that into Houdini Engine and have it instance, for example, inside of Unreal or Unity as instant static meshes. Do note, however, that you cannot use Physics Painter interactively inside of the Houdini Engine plugin, not because it can't do any simulation, because Houdini Engine can do simulation inside of the engine. But the thing that's missing is the draw functionality. Unity and Unreal don't have a drawing functionality like you have here in Houdini, so there's no way for Houdini to know where you drew the curves for it. Yeah, and like I said before, you can just simulate using the right key, but you can also go back in time by just pressing the left key. That allows you to really fine tune which frame you would want. So it has a really high level of art directability. Another cool thing that we added not too long ago for the Quixel project is this paint bucket mode. And what this paint bucket mode does is it does the same that we saw before, but now it actually just paints, a large amount of geometry. So we can, for example, say, only put 5 in each bucket being, the red sphere that we have here. And we can increase or decrease the size of that as well by holding Shift and then moving our scroll wheel. So just by clicking, we can add a couple more objects there. And then we can just simulate, that entire paint bucket in one go. So this is much, much easier than, for example, setting up, a DOP simulation network or, having objects and having them fall down. This just interactively lets you paint that. And if you dive inside Physics Painter, we can see that it has quite a bit of nodes here, but the ones that are really important is this DOPNet here. So if you want to make any, big changes to Physics Painter and how it does its simulation, just dive inside and you can just change the bullet RPD solver there or any of the other properties that you have. Another cool thing that you might be interested in is this part here. This part here actually does the instancing part. So out of Physics Painter, we get our low-res geometry. So if we look at our wireframe, need to unpack it, otherwise we can't see our wireframe. We can see that this is our low poly, so our simulation mesh. But what comes out of this guy here, after we put it back where it should be, we can see that it now, actually instanced the high-res geometry. So there's some cool Vex code in here and in these two here to show you how you can actually copy transforms from a low-res geometry and onto a high-res geometry so that you can have this match. Let's see. Are there any questions regarding this?
Yeah, I think you have a couple. Just going back, Martin asked a question which Louis kind of answered. Is there any particular reason why you always put the display and the template flag on?
That's just my habit. That's just me. There's no real reason why I do it. I just always forget to turn off the template flag, so that's it.
And then how does material management work with Physics Painter? Can you use the GameDev quick mat for each mesh?
Yeah. So what the tool does is it expects, just geometry. So what you could do is, for example, put your GameDev quick material on here, and it will create a material. So now you can see that we have a shop material path. And then what Physics Painter does all the way at the top here, this is where it imports the objects. It will pack it to make it a pack primitive, right? So if we look at our scene here, we can actually see that the pig head, after it comes out of Physics Painter, still has whatever attributes, whatever material it has assigned before it goes in. So any of these groups we still have. Is this not closed? Yeah, so that answers that question, I think.
Yeah. So Mohammed actually brought up a point about like, can you tile stuff? And by the way, Paul, whatever you're showing at the moment will go out. So in terms of using this to actually create tileable textures, and since we also have the mesh tiler, I don't know if it's a stretch for you to show how this would feed into that, or if you want to do a quick sort of demo of that, or should we leave that for the next office hour?
Yeah, we can. I can quickly show the mesh tiler. The settings thing that popped up was just me trying to disable the notification so it doesn't hide Houdini. If we go into our GitHub folder that you have on GitHub, right? This is just me. I saved a local copy on my disk. If we go inside of HIP, we can find all our demo scenes, and inside there, we can look for the mesh tiler. There we go. We don't need to save that. We can see how to set that tool up. I think it's just calculating something right now. What is it you would like me to show for?
Well, I think Mohammed was simply saying that if you use the physics painter to drop a bunch of objects down, could you then take the all the objects that have been dropped down and create a tileable texture from the result of that?
Yeah, of course. That's what I'll show right now. Actually, you can see here at the bottom of my screen that it's doing a physics simulation right now. It's doing a DOP sim. This scene that I'm going to show you, what it does, it just has a sphere with a bunch of bricks copied onto the points, and then just has those simulate to fall down onto a pile or something like that, and then that plugs into Mesh Tiler to make it tileable. So yes, that is definitely possible, and that's what this scene will show as soon as the simulation is done. Any other questions in the meanwhile?
I think those are most of them. There was a question about bending and deforming, but I think we'll answer that in chat and then maybe show an example of that a little bit later.
Yeah, okay. It's at frame 60 out of 70, so 10 more frames, guys.
Yeah, the other thing that was kind of cool with the physics painter that we didn't kind of harp on, but it's a cool feature, is that you can go back in time and choose whatever feature or whatever frame you want to kind of freeze and dry the paint, which lets you kind of control the simulation as opposed to traditional physics sim, where you just have to wait for it to settle. You can kind of not settle all the way and kind of catch things and as they're rolling downhill and freeze them.
Yeah, exactly. That's a good point, Louise. Yeah, so let's see. We have our geometry here. So to answer your question about the simulation part, we have our brick geometry here, right? We have this simple brick. Then we have a sphere, this guy here, and as you can see, it has lots of points. And I'm simply going to use a copy to points to copy lots of these, bricks onto these points, and then that goes into a DOPNet. And this DOPNet, as you can see, is just a physics simulation. So this would be your physics painter node, right? It's just a DOPNet without the physics painter as a wrapper around it. Then what I do is I just unpack some stuff here. I have my my grid mesh. This is the surface that I want to tile it on, right? So it doesn't need to be a quad. It can be a rectangle, can be anything like that. And then if I plug that into Mesh Tiler, we can see that it made that tileable for us. There we go. So if we were to, for example, pack that back up again and we copy it, we can see that there's no seams here, right? There's no weird bricks that are sticking out. If we, for example, were to bypass Mesh Tiler and instance our original stack, we can see that we'll have some weird results with lots of intersecting stuff. Or if we were to do a Boolean to cut the borders to clamp it, we would also have weird, ugly seams. So that's that. onto the next thing. Let's show the Rebirth demo, since that's a question that got asked. I'm just going to discard that and stop the cooking. Okay, so this is the scene that you might have seen. Let me just set it to manual. This is the scene that you might have seen in the Unreal Engine live stream that we did, but we didn't go through it. We just showed it working. But I'd like to just go step by step through what the tool actually does, or the scene rather. It's just a tool, but in a HIP format. So with the sub multi-file, you could, for example, just say load multiple, and it would, load up either, a single mesh. So in this case, this guy here, or it could load up, an entire library. So for example, the Quixel Megascans library that was made specifically for the Rebirth demo. Then what I do, since I knew that every single file that we're going to load had this sort of naming format, right? It had this ID code and then had underscore and high. So what I did is I just took a wrangle and said asset ID split that name that you have, which I just showed you in Explorer, and take the first part, so the ID code, and that just gives me, a name attribute that I can use to loop over, right? So that's that. Then next up we have this this Python SOP, and what this Python SOP does is it scans the rest of the directory. Let me just delete these LEDs. It scans the rest of the directory that it got this asset from, to see if there are any of these textures. So for example, we can see that it looks for a roughness map, it has one here. It looks for a displacement map, it has one here, and it looks for a fuzz map, it has one here. Not every single asset has all three of these maps, so that's why I created some attributes on the geometry that's being processed to tell it what is the location of the texture, where is this guy located. So in this case, if we were to go to properties, we could see that it's located at this location with this texture. Then we just made or added some really hard normals to our geometry. So in this case, everything looked really faceted because it gave all the geometry that you see, like the rocks, a really crisp look that we wanted. But some of the parts, like for example, where you have a rock and it has some moss on it, the moss has to look soft, right? It doesn't need to look hard. So that's where this attribute from map would just look for that attribute that we just created. It would look if there is a fuzz map. If not, just bypass this step entirely. That's what this switch does. If it is there, it would just take this black and white mask that we have and add this as a color attribute onto our geometry. Right, so now we have a mask on our geometry for that. Then we just blur it to make it have a nice soft transition, and then we group every single point that has a value higher than 0.2. So that was just an arbitrary value that we decided that worked for us. So now all the points that are white, or in this case where there is fuzz present, put those in a group and add really soft normals. So now we've softened the normals of that region, and then we just blur position value to make it look even softer, and then we just delete the color again because that was just a temporary thing. We delete the group to do some more housekeeping. We delete all these other attributes that we created because we don't need them, because down here we have these FBX ROPs. They would just otherwise save these attributes to disk, meaning the FBX files that got exported would have a lot higher file size, right? So to create the LEDs, we needed to have separate files for the LEDs. So we just used the polyreduce, LED 0 being 50% of it, LED 1 being 20% of it, and LED 2 being 5% of it, and an even higher reduction if it is possible. Then this LED tool here, or the FBX output ROP, has a Python expression inside of the output file parameter. And if we click on edit expression, we can see that it has some Python code in here. This would just really easily grab some of the attributes that we created up here. For example, what is the directory that our asset is currently located in that we're processing, and what is the asset ID? So in this case, that would be SIZXL. Add FBX to it and just export it. So that's what those three things do here. Then we see that a line continues. So the next thing it would cook is this Python SOP, and that would just call these guys here. And then last but not least, it would do something with the textures, because we still have our displacement, fuzz, and roughness map. It would want to channel pack those. So for example, the roughness goes into red channel, displacement goes into green, and fuzz goes into blue, or something like that, right? It doesn't need to be exactly like that, but that's the basic idea. So inside this copnet, once again, we have these files here, once again with an expression. It would once again grab the file path from the attribute that we created above, load that in, same for the displacement and the fuzz. It would do some modifications to the displacement map, set the brightness to 0, some more stuff. And then we just use a channel copy to say, put roughness, in this case we see in red, put displacement in green, and put the fuzz, if it is there, in blue. All right, that's what this bright does. It just sets it to black if there's no fuzz map available. That's what this switch does. And then once again, we have our rob file output, which has an expression. Once again, grabs the directory we want to save it in, our asset ID, and just save it as a JPEG. And that leaves us with 3 LODs and a channel pack texture for every single asset that you have here. So why would you do this in Houdini? Well, as you can see, there's quite a few steps that you need to do for every single asset. And imagine having to do that for over 100 assets, right? That would, first of all, take a really long time. Just loading that file could take, I don't know, let's say 30 seconds. Then you'd have to load in the textures. Remember, it's really high resolution textures, so that could take a while too. Then you'd need to do a poly reduce and save it out. But now we only need to tell it, here are all the files, run the entire thing, do it for every single file, and we can just go and have a coffee or have lunch or something else like that, and automatically we would see that in our file directory for the project, it would spit out all the processed files. Are there any questions regarding that?
I haven't seen anything come through on the chat.
Cool. Yeah, if there's no questions regarding that, we'll just continue on the next thing. The next thing is some more asset processing stuff, or automation, I should rather say. And that's going to be about what we do internally to test all our tools. So what I'm going to show you is actually public as well.
Hey, Paul.
Yeah.
I think since we showed some of the Rebirth stuff, one of the things that people want to see as well was the procedural smoke.
Yeah.
And Mohammed was also asking about how to bend and break stuff, and I might be able to show a quick example of that. So why don't we do that, and then we can come back to
that's a good idea.
stuff.
Let's do that. I'm just going to switch to Skype so you guys can see what Mike's doing.
And make sure I've got the right window. Okay.
Let's see, how do I focus? There we go. All right,
so hopefully this works. Okay, so I think similar to what Paul was saying, we showed a lot of the stuff at GDC and in videos, but we kind of fast forwarded it so quickly that you never really got a chance to kind of see how that stuff is broken down. And one of the things that we did was provide kind of this procedural smoke asset for the Quixel team to very quickly churn out a bunch of texture sheets. And the idea behind it was that instead of them having to worry about doing actual simulations, was there a way we could just do procedural smoke that had enough movement in it to kind of give us what we needed? And that's kind of what this file is. I can share this, but I can also probably, I am going to be wrapping this up into a tool, so it will come eventually. But the basics of it is actually to work on points first and then change that over or transfer that, rasterize that into a volume. So the very first thing that I actually do is I just take a box and I just fill it with a bunch of points. So what you're seeing here is through a specific camera, but if I break out of that, you can see that it's basically just a bunch of points this way. And the reason that I personally did it this way was it meant that I could visualize the points, but I could also look at the point data. So I can actually have a look at my spreadsheet and kind of see what's going on. So the first thing that I did was I just added noise. We have this attribute noise node that you can drop down. It's got a couple of settings, and I kind of tweaked and played with that. And if I just show you the kind of the result of that, I get something like this. So nothing really too fancy. My goal here was to keep it as kind of low res and get the overall shape first, and then worry about going in and doing the detailing. And the reason for that is it's really quick for me to kind of make changes to this and then see those changes update in my viewport. So I find that when you start dealing with simulations, or you're dealing with really high-res volumes, that update speed slows you down quite a bit. But if I'm just dealing with points and I'm visualizing those colors, then it goes a lot quicker. I think I can see it over here. Yeah. So this is actually just showing that results directly on the points. You kind of see that my updates are relatively quick. So if I was to play that, there's actually some offsetting happening into the noise, which gives me some basic motion. But if I was just to use this on its own, it's a little too simple in that it's only giving me one sense of motion. And so what I did is I had a second noise with very similar settings but different offset settings that I blended together. So it's just a simple smooth function that says, give me the result of this and the result of this, and fit it between 0 and 2, and then output that as my density. And so that's what I'm getting when I kind of have a look at this thing here. And there's just a very subtle kind of like upward motion that's happening here to break up the horizontal motion of that. And this meant that you could go in and change both the motion as well as the kind of the overall shapes just by playing with a bunch of sliders on these guys without having to worry about re-simulating every single time. So once I had that, remember that this is going to be a tileable, or not a tileable texture, but a texture sheet. And because of that, I wanted to kind of fade out the edges, but I wanted to do it in a way that didn't just give me a hard kind of fall off over there. And so to do that, I used another angle. And you see if I turn this on, we get that. And by the way, this is a trick that I've done in Unreal as well before. It's more kind of smooth functions. Basically, I take the result of my density, which is this over here, and I add that to a ramp, which is going from the edge over here to the edge over here. So it's ramping up and then ramping down. And then I'm doing a smooth of that. And the reason that I do that is it gives you these really nice kind of breakups along the edge. So instead of giving me this harsh line, where I have more density, it's going to kind of let that bleed in closer to the edge, and where there's less density, it's going to kind of fall off nicely, and so you get this result over here. So if I play that back, you can kind of see how it's kind of popping in over there and then kind of disappearing over there, but it doesn't feel like just a ramp multiplied against it, which gets rid of it. So I thought that was really helpful. And then once I'd done all of that, the last thing to do was to actually add the high-res detail, or to make this a little bit more interesting, because at the moment these shapes are pretty low-res. And so I actually rasterized this to a volume first. And the reason I did this separately is that this is when it will start slowing down. So I want to do this as a secondary step so that I can, like I say, get my motion in place, I get my shapes in place. And then hopefully this is something that doesn't require too much tweaking on the regular. So you'll see here that this really kind of goes in and starts breaking down that shape further, and gets me a lot of nice detail. And this is basically just another layer of what's happening up here. So this is kind of low res noise, and then this is high res noise. And what I'm doing in here is I'm creating a turbulent noise, and I'm multiplying it against the result of the density, and that's just going to kind of eat into it and give me what we see here. I could have done this a little bit more of a complex way. One of the things you can do is you can actually sample into the density or choose a new position and sample into it, which is how you do gridless advection. But I think for this stuff, it wasn't really necessary. This kind of gave us what we needed. So that's essentially what's happening here. Those are the different layers to it. And with that, I can now render this out as a sequence. And because, probably should have mentioned this earlier, this is I wonder if I did it here or did I? Let me just double check. Time shifts, volume trail. Okay, yeah, so I actually ran it through the make loop tool that we have. This is just the GameDev make loop tool, and then made sure that my first frame and my last frame would line up. And that way, when I rendered it out, I would get a looping texture sheet. So that's kind of the basics of how this worked. I'm wondering if I missed anything or if there's any questions around that. No, it doesn't look like it.
No, it doesn't seem like there's any questions.
Okay. Paula Louise, is there anything else you think I should have covered around that?
Yeah, can you talk about which parameters you actually exposed out to? Because it's a big network that does a lot of stuff, and I'm wondering what are the kind of critical pieces to kind of control the look.
Sure. So I would say the critical pieces are the noise, the add noise, and this is basically just giving you all of the different parameters you could change on a noise function. The ones that I cared about the most actually were just element size. Because I was using simplex, like I kind of know what I'm going to get out of it. And then it's also the offset. So this is where it's actually doing the motion change as it kind of moves along in time. Those, I would say, were the only things that I really cared about for this. And similarly with the second one, both of those over there. Where else, Louise, would you be interested in kind of what I was exposing?
No, I just know that we kind of packaged this up for them, and they were the ones that actually generated the different flip books for them. So I'm just curious, like if that's all they really needed to control, or just the different types of noise, or if there's.
Yes, I think in terms of the stuff that they needed to change, or that you would need to change, is these up here are going to give you your big shapes and your movement. So that would be the first thing. You generally don't need to touch the fading to the bounds, because you're just really making sure that all stays within the render. So the next thing would have been the extra noise detail, and here I exposed the frequency and a ramp, so you can kind of choose how much you want to eat into it. If I play with that, you can kind of see that happening over there. Or if I play with the frequency, how much kind of noise we get to add to that. And then once again, I'm just doing a slight offset in time so that we get a little bit of rolling kind of motion. So they would have changed that. And then this literally was just to increase the density. So in order for it to render a little bit clearer, I added this in because you can see that I just needed it to pop a bit more. So I would say those were the three things. It's your initial noise, it's your extra detail noise, and then your overall density to just make sure that renders out.
Cool.
Yeah. So hopefully that helps. Okay. So Mohammed was asking about bending and breaking stuff. I'm going to show a very quick demo of how you might do that with soft constraints. And the reason I say very quick is I could easily spend an entire week on this. But I do want to point out something if you want to have a look at this. If you drop down, and because I'm sharing a single screen, you'll have to bear with me because I won't be able to bring up my browser. But if I drop down a .NET, and then inside the .NET, I drop down a bullet soft constraint relationship node. If you click on the help icon for the bullet soft constraint node, it'll bring up the help card. And at the bottom of that help card, there is an example. called soft constraint network. So if you click on load, it will load this into your Houdini session. And that's what I'm about to show you. But if you're at home and you want to kind of try this out for yourself, what I'm about to show you is already available as an example, and it comes with Houdini. So let's have a look at that. So this is what it's actually going to drop down in your Houdini session. And essentially the easiest way to deal with bending and breaking, if you're dealing with rigid body dynamics, is to use soft constraints. So without going into like what every single node does here, I am going to kind of try and simplify it and then kind of add stuff back as I go. So in this particular example, all I really want to show is how you can take multiple rigid body objects and connect them together, and then how you can control the bending and then eventually the breaking of those connections. So to set this up, we're actually just using a bunch of spheres. And if I then use an assemble SOP, it will pack those spheres into packed objects, which is very important when you're dealing with bullet sims, because most bullet sims you generally want to use this for memory reasons, and just trust me, it works better that way. And what it's done is it's given each one of these spheres a name attribute. So once we've got all of that, that's going into our DOPNet. And in the DOPNet, the things to care about are the RBD packed object, which is bringing in the spheres. We've got a rigid body solver, which is using Bullet to drive this. And then just a ground plane and a collider to run this again. So if I play this as is, it's just a bunch of spheres falling, doing their thing, nothing really special about that. So what I want to do is connect them all together and then have those connections bend. And the way that we do that is by using connect adjacent pieces. So with all my spheres, I can connect adjacent pieces. And you'll see we get this crazy network of line segments. And there's a couple of different settings for this depending on what you're trying to connect. So you might need to play with this to figure out which one works for you. But now that we've got these line segments, I can add a couple of attributes which are specifically for soft constraints and for constraints in Bullet. And in fact, this is an older demo. If you now use the RBD constraint properties node, it'll actually set a lot of this stuff up for you. So that's just something to keep in mind. But essentially what this is doing is it's creating these attributes to say what kind of constraint is it, what is the length, the initial length of each piece, and then that's feeding it into our simulation. So what I can do now is I can actually use, I'm just going to break this for a second, a constraint network node with a soft constraint node, and this is actually where that name comes in handy. So you would have seen out here that there is this name over here, constraint name soft. That is so that it connects up with these guys over here. So notice that in my sim now, we can actually see those connections coming through. And if I play this as is, you'll see that they will now basically connect to each other. So I will let that go a little bit more. So now we have something where we could essentially build something that bends depending on those settings. So if I drop this stiffness down, let's try 100. It's probably going to be a little too soft, but let's give it a go. Yeah, it's not too bad. Then you can see how we can now get something that isn't just a rigid object, but actually has some bendiness to it. And then the last piece to this is at some point I want those connections to break. And to do that, we actually use a geometry wrangle. And the reason for this is that when you create these constraints, when the sim is running, it actually generates a bunch of attributes. So let me see if I can find these attributes so I can show them to you. Might be in here. Not there. Constraint geometry, yeah. So these attributes are created inside the simulation. You'll see there's a force and a torque and a distance, and these are updating every single frame. So what I can do is I can say if one of these attributes becomes a certain value or it changes, then break that constraint. And that's what this is doing here. It's saying that if the torque is greater than the max torque value, which we've assigned over here, then just delete that connection. So let's actually see if this decides to work for us. I'm going to drop that down real low just so we can see if we get anything out of it. There we go. So you can actually see those connections are now breaking. So what I would need to do is kind of figure out where the kind of sweet spot is between I want these things to bend, but then when I want them to break, what is the torque value that would allow me to do that? So that's just a very quick explanation of how you might do bending and breaking with soft constraints. We've actually got some pretty cool stuff coming, I would say, later this year, specifically to do with bending and breaking. But hopefully that gives you at least a starting point to have a look at it. Are there any questions around that stuff?
No, it doesn't look like it.
Oh, so this is going back to the Quixel, the procedural smoke stuff. Yeah, it will be a game dev tool. I will be turning that into a game dev tool. Yeah, so I think that was it. Cool.
Yeah, which at some point will become a labs tool, right?
Yeah, eventually. But we'll save that for later.
Cool. Let me just go back to what I was going to show with the automation stuff. So I was saying that on GitHub, all the files that we post, right? So these are all public files that anyone has access to. There's this folder here called tests, and these are actually tests that we run internally every single time we make a new build, right? So you get a daily build, but we want to make sure that the tools still produce the same kind of output. That, for example, there's no warnings when you create a tool, or no errors at least, right? And that's what these files here do. So how can you run these yourself if you want to see how to use those? What I like doing is just creating a bat file, which you can just create by having a text file and then typing some commands here. So in this case, I told it run Python and then have Python run this script, which is just this script here, and then pause it so that I can see the console for that. So if we look at this run script, we can see that the first thing it does is it checks, okay, I want to run these tests in Houdini 17.5. In this case, I was just going to test it in 17.5, but I could, for example, run all these tests in, I want to test 17.5, I want to test 17, I want to test 16.5 and 16 and so forth. This function, get latest Houdini version, just looks at this folder. In my case, I have a specific custom location, but by default, it would look in program files. It would check what is the newest version of Houdini that we have installed. So in this case, for me, that is 17.5.327. And then it looks into this directory where this run file is located, and it checks if there's any of these test files. So in this case, anything named test underscore and then whatever it is, it will execute that test for us. In this case, I don't want it to test everything. I just wanted to show one of them, test demo files. It will just look for the file that says test demo files, and then you can see that it will actually in the Houdini install folder find Python, right? This is just Houdini without a GUI attached to it, and then have that session of Houdini, in this case, Houdini engine, run the Python file that we saw here, which means it will run this file here that we see, test demo files. And then what this test demo files does is it sets up this unit test class for us, and then it finds all the hip files, so all the test hip files that we saw before, like for example the one from Physics Painter or anything else. So all these hip files that you have access to, it is going to open those files, and it will see if there is any GameDev nodes in there that are using an older version. Like I showed before in the beginning of the stream, it had version 1 of Instant Meshes or version 2 of Instant Meshes. It would check that every single demo scene is using the newest version of every tool. And it would also check if there are any warnings that pop up. For example, a tool is missing, or it's missing some textures, or it's missing some geometry. And then it just outputs that to the console. So if we were to run this bat file, we can see that it's running this Python file that we saw, and it's just going to open every single demo scene and do the test that we saw. So while that's running there in the background, we'll see that it will show us a warning if there's anything. So there we go, it tested that scene, it tested the other scene. And here we go. It found that one of our tools, AutoUV, is using the old version of the measure curvature. So that then tells us that we need to go update that tool because something is missing. So that's one of the tests. The other test that we do is the test demo files output, which is somewhat more recent. What this tool does, or this script, is inside this test folder, there's this hip folder and another one called shared, baseline. Inside here, we have geometry output from, for example, the color adjustment demo scene, right? So the color adjustment SOP gives this result that we've manually verified. This is the actual real result that we want to have from the SOP. So then what it does is it opens that demo scene from the color adjustment SOP, exports out one frame of it, and then down here it will actually use GeoDiff, which is a utility tool that Houdini ships with, and tests the baseline file that we've manually verified against what is currently being exported from the demo scene. And if those are similar enough, the test has succeeded, and we know that color adjust tool is still working properly. So this is very useful if, for example, I modify the color adjust tool and all of a sudden it only outputs red color even though it should be blue, then we will get an email or a notification that says, hey, this tool does not work the way that it should work. And then we can manually verify that whether or not the change that we made is correct. It always needs to be red, yes. Then we update the baseline file manually. If not, then we just fix the tool and fix the bug that we have there. And that's an ongoing process. So there's a couple more. For example, the maps baker, it compares, if the maps baker output is still the same like it should be, and all the other tools as well. So that's just something that I quickly wanted to show because it's an important tool or workflow to make sure that your tools actually work. So that's another way of doing automation, just using Houdini without a GUI, so just command line. Yeah, and that's I think what I have to show for today. I can see that we've streamed for an hour. Are there any questions regarding this before we finish the stream?
I didn't see anything in the chat, so I think we're good. And if people do have any questions, they can always drop them into the Discord or send them to us directly, and we can cover them next week, or the week after, should I say.
Yep. So if you're in the stream and you're not in the Discord yet, make sure that you join it. I don't know if we've promoted it on the SideFX website or somewhere to get the invite link, but that's the place to ask some questions or have requests for next or the next 2 week stream.
Thanks, Paul. I think the second one went a lot better than the first.
We'll see.
Yeah, good stuff.
Awesome. Cool. Then I'll end the stream. Thanks, everyone. See you next time.